Okay, in this lesson we looked at graphing logarithmic functions and exponential functions. So we're going to do 3 of each today. You see at the top here what your parent functions would look like for a lot of these. So your logarithms result in a function either like this first one, if the base of your logarithm is greater than 1, indicating some sort of growth. If your base is less than 1, or I should say specifically between 0 and 1, then it would look like something like this, indicating some sort of decay. Okay? And so we know ahead of time as we graph our 3 logarithms, they're all going to take some shape along those lines. You also have a picture as a reminder, because like I said, we'll do, additionally speaking, 3 exponential functions, just so we've reminded ourselves of how those are graphed. You have a picture here to remind you of kind of roughly speaking what an exponential function looks like. It would be going up like this if it was growth. It would be coming down, so reflected over the y-axis almost. It would be coming down if it was some sort of decay. So we know ahead of time again that our exponentials are going to take some sort of shape along those lines. Okay, and so here we go. Numbers 1, 2, and 3, we're going to do number 1 together, and then I would recommend that you pause the video, give number 2 a shot on your own, restart it when you either have an answer or are stuck, whichever one you prefer, and then do the same thing again with number 3, pause the video, restart it when you're ready, either to check your answer or to get a little bit of help if you do get stuck. Okay, so here we go. Number 1, we've got some steps off to the side here. We're going to start by making sure that our function is always in its standard form, which is like this, y minus k equals a times log base b of x minus h. As I look at my number 1 here, I see I have y equals log base 2 of x. There's nothing outside of the logarithm being added or subtracted to it that I can move over as my k. And so I'm already in my standard form. Okay, step 2. I'm going to identify and plot my HK as an open dot. So HK is going to operate the same way it has for all of our other graphing functions. HK, the H is what zeroes out the x component of your function. The K is what zeroes out the y component. And so in this case, what would zero out the x would be 0. What would zero out the y would also be 0. And that's my HK. I'm graphing it as an open dot because, like with the exponential functions that we learned last semester, the HK shows you where your asymptote is. Now with an exponential function, that asymptote is a horizontal asymptote. Because a logarithm is the inverse of an exponential, so everything is reversed, everything is switched. Instead of having a horizontal asymptote, we are going to have a vertical asymptote, like this, right through that HK point at 0, 0. Okay. Number 4, we are going to identify and plot 2 key points, and then potentially speaking our y-intercept, and then we're going to connect. So with your 2 key points, you can plug in whatever numbers you want, but like with exponentials, there are some kind of key ones that you want to keep an eye for. The first thing is what would generate 1 inside of my logarithm, because log base anything of 1 is 0. And so if I can get my value inside of the log to say 1, then I will already know that that term would end up becoming 0. And so for this function, that's a fairly simple step, which is what would make the guts equal 1? Well, 1. And so then log base 2 of 1 would be 0, and there's nothing else being added or subtracted, so it would just be 0. And that's my first coordinate point, 1, 0. In terms of your other point, you want to think about values that you can fairly easily either calculate or approximate inside of your logarithm. So in this case, because we are log base 2, potentially speaking, we'd want it to say log base 2 of 2, or log base 2 of 4, or log base 2 of 8, or something along those lines, because I can evaluate that term. And so maybe we make x equal 2. Because then I have log base 2 of 2, which is 1. So 2, 1 is another point. And then you could continue to do this for any of them. I could make this log base 2 of 4, because then my y would be 2. I could do log base 2 of 8, then my y would be 3. You could even think a little bit outside the box and do maybe log base 2 of 1/2, which would be -1, right? So you could do any of those values. As long as you have at least 2 points, you will be able to construct a curve for yourself here that looks like the logarithms modeled up above. Okay? And so then we're identifying x-intercept, y-intercept, domain, range, and vertical asymptote. So x-intercept is when y equals 0. So 0 equals log base 2 of x. Okay, to solve for my x here, I'm going to do the inverse operation of log base 2, which means raise both sides above the 2. Those then cancel, and I'm left with x equals 2 to the 0, which means x equals 1. And so my x-intercept is at 1, 0. My y-intercept is when x equals 0, and so we're looking at what would give me log base 2 of 0. And unfortunately, you can't evaluate log base 2 of 0, and so in this one I end up with no y-intercept. And both of those you can confirm by looking at the graph, right? I see my x-intercept here at 1, 0, and I see that I never touch my y-intercept because it's a vertical asymptote, giving me no y-intercept. But it's good to remind ourselves of why those two things are true. X-intercept is when y equals 0, y-intercept is when x equals 0. Okay, for domain here, my x values would be everything from 0 to infinity. My range are my y values, which would be -infinity to infinity. And my vertical asymptote is on the y-axis. A vertical line is x equals, a horizontal line would be y equals. But my vertical asymptote is x equals, and in this case it's x equals 0. Okay? Okay, so using that one as a model, I'm going to recommend again that you pause the video, give number 2 a shot on your own, see how far you can get, and then restart the video either when you're stuck or when you have an answer that you'd like to check against. Okay? So go ahead and pause the video, give number 2 a shot. Okay. Number 2, we're first going to look to see, are we in standard form? Well, there's nothing outside of the logarithm being added or subtracted that needs to be moved over with the y, so we're good to go. Okay, so next up, we're identifying what is my hk. Well, what would zero out the x component? That would be -2. What zeroes out the y component? That would be 0. And so my initial point is at -2, 0. And remember, for a logarithm, that is a vertical asymptote. Okay? And then I need at least 2 other points here, so construct a little x, y. First one, like I mentioned earlier, I recommend always trying to get a 1 inside the logarithm. And so in that case, that would mean x would need to be -1, because then -1 plus 2 would be 1. And the log of 1 is always 0. And then there's nothing being added or subtracted to that term, and so my point is -1, 0. Now your second one for this one is going to be a little bit interesting because natural log, we don't really know what like the natural log of 2 is or the natural log of 3 is. I mean, we can use our calculator to evaluate that, but if you don't have your calculator, well, now you have to do some sort of approximation. Okay? So there's a couple of options. Option 1, maybe you plug in x equals 0. And so then you'd be evaluating the natural log of 2, which I don't know what that is. But I do know what the natural log of e is. We learned this in a prior lesson. Natural log of e is 1. And e is about 2.718. That's also from, I think, the first lesson of this unit, if I remember correctly. Well, if the natural log of e is 1, and e is 2.718, then the natural log of 2, which is what I'd get here, would be a little less than 1. Right? Because natural log of 2 would be less than natural log of 2.718. So we're looking at something less than 1. So maybe you plot that point, 0 less than 1. Something like that. Actually, technically speaking, if you did want to evaluate natural log of 2, if I remember correctly, I think it's about 0.69 or somewhere around that zone. So a little more than half, but less than 1. Okay? Option number 2, if you aren't comfortable with that one, well then you could do what would x need to be to get me pretty darn close to e. Well, if x was 0.718, then I would have 2.718 in there, right? And then that would be about what natural log of e is, and natural log of e is 1. Okay, so then you could plot that point, 0.718, 1. So, a couple of different options there. You could also do some sort of other approximation method to generate your term. But something along those lines. Okay? Okay, so then x-intercept, y-intercept, domain, range, vertical asymptote. So x-intercept is when y equals 0. Okay, so putting 0 in for natural log of x plus 2. To undo this natural log, we're going to do its inverse operation, which is raise both sides above the e. The e and the natural log cancel out then, and we're left with x plus 2 equaling e to the 0, which is 1. Subtracting that 2 over then, x would be negative 1, which again we can see confirmed here at negative 1. Y-intercept is when x equals 0. And so we have y equals the natural log of 0 plus 2, which is the natural log of 2. Which, since we have no idea what that is, like I said, if I remember correctly, it's about 0.69. But since we don't know officially what that is, we're just going to write that as natural log of 2. Okay, domain are my x values. So my x values here would be everything from negative 2 to infinity. Range are my y values. We're talking negative infinity to infinity. And then vertical asymptote is an x equals line, and in this case would be x equals negative 2. Okay? Okay, last one. If you haven't already, pause the video, give number 3 a shot, restart it when you are either stuck or have an answer. Okay, number 3. I do now have something added or subtracted that needs to be brought over as my k. So for my standard form, we have y minus 1 equals log base 4 of x minus 2. Okay, so my hk in this particular case would end up being 2 for zeroing out my x and 1 for zeroing out my y. So there's my vertical asymptote. Okay, for 2 additional points here, again, I always recommend starting with what would give me 1 inside my log. Well, in this case, 3 would give me 1 inside my log. 3 minus 2 would be 1. So log base 4 of 1 is 0, plus 1 is 1. Okay, and then for your other point, this one is log base 4. So potentially speaking, you might want to make the inside equal 4, because then log base 4 would be 1. So that would mean maybe doing 6 for inside your logarithm. 6 minus 2 would be 4. So log base 4 is 1, plus 1 is 2. Other ones that you might potentially consider would be log base 4 of 2. And so that would mean making your x 4. Log base 4 of 2 would be 1/2. And 1/2 plus 1 would be 1.5. So you could always do that point as well. Or some other value that you feel like you can evaluate fairly quickly. Fairly easily, or at least approximate. Okay. Okay, x-intercept is when y equals 0. So if I put 0 into my y here, actually I'm going to put it into this one. 0 minus 1 is -1. And we have our log base 4 of x minus 2. It doesn't matter where you plug your 0 in, by the way. These two equations are the same. So you could plug in 0 to either y and then solve for x. So I'm plugging it in here. 0 minus 1 is -1. Okay, inverse of log base 4 is 4. And so we have these canceling. We're left with x minus 2. And 4 to the -1 is 1/4, or 0.25 if you prefer the decimal. And then adding 2 over would be x equals either 2 1/4, 9/4 if you prefer a complex, not a complex, I'm sorry, if you prefer a not mixed number, a fraction, or 2.25 if you prefer the decimal. So all of them work. I'm going to write it as 9/4 myself. And so that's my x-intercept. Y-intercept is when x equals 0. So putting 0 into x there, we have y equals log base 4 of 0 minus 2 plus 1, okay, which I end up with log base 4 of -2, which there's no exponent that's going to turn 4 into a negative, and so I have no y-intercept, which is confirmed by looking at my graph. I never touch the y-axis. Okay, domain is all my x values, which is everything from 2 to infinity. Range are my y's, -infinity to infinity. And vertical asymptote is x equals, and in this case it's at x equals 2. Okay. And then lastly, we did 3 exponentials as a review of graphing exponential functions there. So same thing, we're going to do one together, and then I encourage you to pause the video and give the other ones a shot at your own pace, restarting the video when either you are stuck or have an answer. Okay. So number 4. Start off by getting it in standard form. We're good to go. So then we're talking HK. In this case, my HK, what would zero out the x component would be -1. The y component would be 0. So -1, 0. Now this is an exponential function, so my asymptote now is a horizontal asymptote. And then I need 2 additional values of x and y. Okay? In this particular case, I tend to recommend getting your exponent to be 0, because then you would, anything to the 0 exponent, well, with the exception of 0 to the 0, but e to the 0, 5 to the 0, 1/2 to the 0, all of those generate 1. And so if I can get my exponent to be 0, I'll have 1 as my answer. Well, that would mean x would need to be -1, and so then my y would be, whoops, 1. Sorry. And so there's my first point, -1, 1. And then second, you can plug in whatever you want. I'm going to plug in 0 for mine. E to the 0 plus 1 is e to the 1, which is just e, which is about 2.718. And so we're looking right about there, 2.718. And I've got my function. Okay, x-intercept is when y equals 0. So we have 0 equals e to the x plus 1. If I did the inverse operation of e, that would mean natural logging both sides, so the natural log and e can cancel. And we have natural log of 0 equals x plus 1, but I cannot take a natural log or any logarithm of 0, and so that tells me that I have no x-intercept, which is confirmed by my graph. Y-intercept is when x equals 0. So plugging 0 into x there, we have e to the 0 plus 1, which is e to the 1, or just e. And so my y-intercept, x equals 0, is e. Domain are my x values, so this would be everything from negative infinity to infinity. Range are my y values, which are 0 to infinity. And then horizontal asymptote, because this is a horizontal line, now we're talking y equals, and in this case this would be at y equals 0. Okay, and so that's a review of your graphing exponentials. Okay. So again, one more time, I recommend pausing the video, trying 5 and 6 on your own, or doing 5 and then restarting the video, but then pausing it again and doing 6 and then restarting the video. Or do them both and restart the video when you're ready, whichever one you feel like you are most prepared for. But at some point, try these on your own. Okay? And so number 5. We've got already in standard form, so my HK is what zeroes out my x and y components. And so in this case, my HK would be 0, 0 for my horizontal asymptote. 2 additional points here. If I can get my exponent to be 0, then I'd have a value of 1. So plugging 0 into x here, we'd have 1/2 to the 0, which is 1. So there's my first coordinate point, 0, 1. And then plugging something else in, whichever one you prefer. So maybe you plug in -1. That would give you 1/2 to the -1, which is 2. Or you plug in 1, you get 1/2 to the 1, which is 1/2. Maybe you plug in -2. That would give you 4, sorry. But some other point to give you that shape of your graph. So I guess I'll plot them all. But it gives you some sort of shape like that. Okay. Okay, x-intercept, when y equals 0, so we have 0 equals 1/2 to the x. Inverse operation of 1/2 is log base 1/2. So we'd have log base 1/2 of 0 equals x. But I cannot log base anything 0. And so I have no x-intercept. Y-intercept is when x equals 0. So we have y equals 1/2 to the 0, which 1/2 to the 0 is 1, and so my y-intercept is at 0, 1. Which both of those, again, one more time, you can see by looking at the graph and confirm. Domain x values would be negative infinity to infinity. Range are your y's, 0 to infinity. And your horizontal asymptote, y equals, in this particular case, this would be y equals 0. Okay, last one, number 6. Pause the video if you're going to. Okay, to get this one into standard form, I will need to add that 2 over to the other side. So we have y plus 2 equals 3 to the 1 minus x. My HK then, H would be 1, because that would zero out the x component, and -2 to zero out the y component. And so there's my horizontal asymptote. Plugging in 2 additional values, or to get 2 additional points. So I might recommend maybe plugging in 0, because then we'd have 3 to the 1, which is fairly easy to evaluate. 3 to the 1 would be 3, minus 2 is 1. And maybe you plug in 1, because then you'd have 3 to the 1 minus 1, or 3 to the 0, which is 1, minus 2, which is -1. You also could plug in any other numbers if you wanted to, but I'll go ahead and stick with those 2 for now. And so we get our exponential function. Okay, x-intercept is when y equals 0, so plugging y in, we have, or 0 into y, we have 0 plus 2, which is 2. 3 to the 1 minus x. Inverse operation of base 3 is log base 3. So we have log base 3 of 2 is 1 minus x. I have no idea what log base 3 of 2 is, but I know I can subtract the 1 over. So negative 1, or log base 3 of 2 minus 1 if you prefer writing that. So subtracting the 1 over. And then dividing the negative, we'd have 1 minus log base 3 of 2, which is your x-intercept there. Which my line is not quite long enough, so I'm going to write this on the diagonal. 1 minus log base 3 of 2, and then your y of 0. Okay. Your y-intercept is when x equals 0, so plugging 0 into my x there, I get 3 to the 1 minus 0 minus 2, which is 3 to the 1, or 3 minus 2, which is 1. And so my y-intercept is at 0, 1, when x equals 0. Okay, domain is x values, so negative infinity to infinity. Range are y's, which in this one would be negative 2 to infinity. And your horizontal asymptote, so where y equals, in this case it would be y equals negative 2. Okay, and that's graphing exponentials.